Hey y'all, in this video we're going to learn how to construct a position time graph from a velocity time graph. So first let's just talk about the general steps and then I'll work you through an example. So typical steps you're going to take is first you want to divide up your velocity time graph into sections every time your line crosses the x-axis or it changes direction. So basically if your slope's changing or you're crossing the x-axis, you're going to want to split it there. All right. Step 2, you're going to calculate the area between your line and your x-axis for each section of the graph. So when you divide your graph up, you're going to get either triangles or rectangles or a combination shape that you'll subdivide into a triangle and rectangle. So this area that you're finding is the distance the object traveled during that time period. Your area formulas you're going to use is just the rectangle one of length times width and the triangle formula of 1/2 times the base times the height. If you get a positive area, meaning your shape was above your x-axis, your object is moving in the forward direction or positive direction, and you're on your position graph, your line is going to slope positively or head up on the graph, right? If you have a negative area, meaning your shape is below the x-axis, then your object's going to move backwards and your line's going to go down on the position graph, or meaning it's sloping negatively on the position graph. And you'll see this work out on our example, right? So once you've found all the areas, you can go ahead and start plotting the distances on the position time graph for each time period. So your time periods will match up, and then you want it to say the same information. So if it's speeding up, slowing down, this is step 4. You want it to say the same thing on your position graph as it does on the velocity graph. So if it says it's speeding up on one, you want it to say that on the other graph. And then you'll repeat this for each section of your graph. So you'll keep repeating 3 and 4 and plotting it. And you'll see that as I go through the example. All right. All right, so let's go ahead and work through this example. So we have a velocity time graph and we are going to make a position time graph. So the first step is to go ahead and divide our graph up into sections every time your line changes direction, like it does here at 3, or when it crosses the x-axis. And then you'll get either triangles, rectangles, or a combination of the two. So you may need to subdivide your shapes if they don't form a perfect rectangle or triangle when you're splitting up your sections. So we're going to split this up. We've got it splitting at 3 seconds when it crosses the x-axis at 6, when it changes directions at 9, changes directions at 12, and then at 15 seconds it ends. So we're just going to close that off to make our shape. So you'll see here for the first 3 seconds, we don't get a perfect rectangle or triangle, so we want to split that up and get both. And same here at the end, we don't get a perfect rectangle or triangle, so we're going to split that up. So the other ones give us either rectangle or a triangle. So I'm going to shade these in just to make it a little easier to see. So for the first one, we've got this triangle and this rectangle. The next 3 seconds after that, we get just this triangle. Then we have this triangle down here, this rectangle here, this rectangle here, and lastly this triangle down here. All right, so we're going to go through and just find the areas for each. So this one's nice because every 3 seconds it changes shape, so we do have several sections to work through here. And you can speed through this if you're good at finding area, but I'm going to just work it all out for those of you that need this. So for the first 3 seconds, we have a triangle. So we're going to find the area of 1/2 times its width is 3 seconds. And I'm going to leave off the units in my writing just to save some space. And then a height of 4 meters per second because it starts at 2 and ends at 6. So its height is only 4. And that's going to equal out to 6 meters because that's seconds and times meters per second. Your seconds are canceling out, leaving you with just the meters, okay? All right, so now we don't have just the triangle for those first 3 seconds. We also have the rectangle underneath, which has a base of 3 or width of 3 and a height of 2 meters per second. So that's also going to equal 6 meters, and we're going to add those together to get 12 meters. All right, I'm just going to write that up here on my graph in case I need to erase stuff later. All right, now for the next 3 seconds, from 3 to 6 seconds, we have a triangle, so it's going to be 1/2 times our base. Our base is only from 3 to 6 seconds, so its width here is just 3 seconds, times the height. The triangle starts at 0 and goes up to 6, so its height is 6 meters per second. So 1/2 times 3 times 6 is going to equal 9 meters. So I'm going to go ahead and write that up here. All right. Now from 6 to 9 seconds, we are now below our x-axis. So our area here is going to be negative. So we have a triangle, so it's going to be 1/2 times the width. It goes from 6 to 9 seconds. So that is a width of 3 seconds. Times the height goes from 0 down to -4. So its height is going to be -4. So you have 1/2 times 3 times -4. So you get an area of -6. And you do care about that negative, so keep that in there. Now from 9 to 12 seconds, we have a rectangle. This has a width of 3 seconds times a height goes down from 0 down to -4. We are going to leave that negative sign in there, and we get an area of -12 meters. Now for the last section, we have two shapes again. So for the box, we have 3 seconds times -2. So we get an answer of -6 meters. And then the triangle is 1/2 times the width of 3 seconds. And its height here goes from -2 down to -4. So its height is -2. And so when we multiply that out, we get an answer of -3 meters. And then we want to add those together. And we get sorry, I lost my train of thought. -9 meters. Okay, now for part 2 to this, or step 2, is to draw your actual graph. So you want to go ahead and set up your graph paper. And I'm going to put my x-axis kind of low on this because I am going in the positive direction quite a bit in the beginning. I'm going to make my x-axis is matched, so the same time interval. So 3 seconds, then 6 seconds, 9 seconds, 12, and then 15. If you space yours out a little bit more, you can, because I definitely left a lot of room here. Then, since my numbers here on my graph, my areas, I have like 12, 9, -6, -12, -9. Like those are multiples of 3. So using 3 on my y-axis would make for a really good interval. You don't have to do that, but that is something to look for if you see any kind of pattern among your areas. All right, so I'm going to go up every other line. I'm going to go up by 3. So 3, 6, 9, 12, 15, 18, and then go up to 21. All right, so now I have my graph set up and I can start plotting my numbers. So for the first 3 seconds, we went an area of 12, and we also want to look at what kind of motion is going on for those 3 seconds. So here on this velocity graph, you have a diagonal line that's going away from 0. It's going from velocity of 2 up to velocity of 6. So that would tell us that this object is speeding up here. So we want to make sure our position graph also shows that we are speeding up for those same 3 seconds. So we're going to go at 3 seconds, and we're going to start measuring from 0. We're going to go up 12 meters, because that's how far we went in that time interval, and we want a line that shows we are speeding up, which is accomplished by a curved line that is increasing in steepness. That tells us we're speeding up. Right? Now for the next 3 seconds, from 3 to 6, we went a distance of 9 meters. Now on our position graph, we're not going to go down to 9 at 6 seconds, because that would imply we're going in the negative direction. We're not going in the negative direction here. We're going in a positive 9 meters. So we're going to add on 9 from this 12. We're starting here and going up an additional 9 meters. So you're going to plot from 12, you're going to add 9, so that would give you 21. So we're going to be at the top of our graph. And I'm going to be at 6, so I'm going to be right here. And then this graph on the velocity graph, from 3 to 6 seconds, I am slowing down because I'm approaching 0. So I want this curve on this position graph to also show me I'm slowing down. So it's going to go up like that. All right. So again, if it's positive area, you're going to be going up on this graph. If it's negative area, you're going to be headed down on the graph. So now this next 3 seconds, we're going down -6 meters. We're not going to drop into the negative section of the graph. We're going to go down 6 from where we are. So we're at 21. We're going to subtract 6, and we're going to be at 15 at 9 seconds. Right? And then we're going to look at this graph and see what is it telling us we're doing. Are we speeding up? We're slowing down, constant. In this case, we are speeding up. So we want to have a curve that also shows us we're speeding up. Sorry, this is kind of poorly drawn here on my iPad. All right, so we're going to go back down. So when you're crossing this x-axis here, that's when you're going to start headed down on the graph. Like your curves are going to change like this. All right. Now the next section, we're going down to negative 12. So we're at positive 15. We're going to subtract 12. That takes us all the way down to 3 at 12 seconds. And then this horizontal line here shows us constant velocity. So we are going to have a diagonal line to also show us constant velocity here. Okay. Then for the last three, we've got negative 9 meters. So we're at positive 30. We were going to subtract 9. So we actually are going to go into the negative part of the graph that I did not label. So let me fill this in. Negative 3, then negative 6. And that's where we are going to end up. And we are slowing down here. I kind of covered the line. But we are headed back to zero, to a speed of 0. So we're slowing down. So we want our last curve to show we are slowing down. Now, ideally, your line looks a little smoother, more consistent than my poorly drawn one on my iPad does. But that's it. Now your position graph is drawn. So let me just recap the steps for you. So we went first and divided our graph into sections every time our line changed direction. Then we went through and found the areas for each of those sections. And then we went to our position graph, set it up. And then if it was positive area, that's how much we went up for that time section, one after the next. And if it's negative, then we started subtracting it. And then we made sure our lines tell us the same information, whether we are speeding up or slowing down. Just like on the velocity time graph, it tells us if we're speeding up, slowing down, or constant. We want that same information translated. All right. So if you have any questions, feel free to reach out. I'll be happy to answer them.